So let's talk about reference angles. We're going to use reference angles to figure out what the values of different trig functions are. The reference angles tell us not only what quadrant your angle is in, but it also tells you the sign of your trig function, okay, and the value. So this is how we define reference angle. So let theta be an angle in standard position. Okay. Then the reference angle denoted by theta prime, okay, is the acute angle formed by the x-axis and the terminal side of theta. Okay, so basically your reference angle is always an acute angle, and your reference angle shares the terminal side with your angle theta, and its initial side, or its other side rather, is going to be on the x-axis. Okay, so as an example, if this was my angle, right, in this case, let's say this is my angle theta. Okay, this is my terminal side. Now here theta is already an acute angle, so in this case theta will be theta prime, right? If the angle is acute, then that is going to be your reference angle. Okay, reference angles are more helpful when your angles are actually more than 90 degrees. So if this was my reference angle now, okay, imagine this being my reference angle. Sorry, imagine this being my angle theta. In this case, my reference angle would be this angle over here, right? Because this now is an acute angle. And like I said in the definition, it shares one side, and that is the terminal side, with the original angle, and then its other side falls on the x-axis. Okay? In another case, we can show, let's say this here was my angle theta, then this here, this acute angle, would be theta prime, right? And that would be my reference angle. So let's look at how do we find the reference angle. So suppose theta is an angle in standard position, and we know that all we know is that 0 is less than theta less than 2 pi. That is basically theta takes all values between, or any value between 0 and 2 pi. Okay, so now if theta is in quadrant 1, then, well, if it's in quadrant 1, then theta is an acute angle, so we know that theta prime is the same as theta, right? Your reference angle and your original angle are the same thing. Case 2, if theta is in quadrant 2, then theta prime is going to be pi minus theta. Okay, because in quadrant 2, right, so this is your angle, this is theta. This whole thing from here to here, right? So I'm going to draw that in another color. This whole thing is 180 degrees. So to get this one, all I have to do is take 180 degrees and subtract my theta, right? So in this case, theta prime is going to be pi minus theta. Well, if theta is in quadrant 3, then theta prime is going to be theta minus pi. Okay, and finally, if theta is in quadrant 4, then theta prime is going to be 2 pi minus theta. Okay, so we can use this, we can figure out what quadrant it is, and we can, using these formulas, we can figure out what your reference angle is going to be. So let's take an example. In this example, we're going to look at how to find the reference angle for these given values. Okay, so we have theta equals 300 degrees. Now if you remember, we need to figure out what quadrant it is in, right? So 300 degrees is between 270 degrees, right? So we know that 270 degrees is less than 300 degrees is less than 360 degrees, which means that is where my theta is going to be, right? This is my value of theta, okay? That is 300 degrees. And so that's going to be in the fourth quadrant, which means to get my reference angle, I have to do 360 degrees minus 300 degrees, and that gives me 60 degrees. Okay. Let's look at 3 pi over 5. Now 3 pi over 5 is slightly less than pi, right? And what is pi? If you think about your angle pi is this angle here. This is the value of pi. And so 3 pi over 5 is slightly less than that, so say somewhere around here, and this angle here is 3 pi over 5. So I need to figure out what my reference angle is. And so in this case, since it's in the second quadrant, I can find my reference angle theta prime by pi minus 3 pi over 5, and that gives me 2 pi over 5. So that is my reference angle for 3 pi over 5, and here it's 60 degrees for 300 degrees. Let's look at the last one now. So we have theta equals 3.2. So the question is that radians or is that degrees? Well, it is radians. If it were degrees, I would have put a small degree symbol over here, so that small circle up here. Since I did not put that, you have to assume here that theta is going to be in radians, okay? So it's 3.2 radians. What does that mean? So far when we talked of radians, we only talked about pi or some multiple of pi, right? But if you go ahead and plug in pi in your calculator, you know that pi is roughly 3.14, right? Or 3.14159. Okay, so this is greater than pi, which means this is going to be in the third quadrant. Now, if it's in the third quadrant, we know that theta prime is going to be theta minus pi, or which is going to be 3.2 minus roughly 3.14, and that gives you 0.06, right? So the reference angle for 3.2 is going to be 0.06 radian.